Okay, so in this next video, I'm going to explain the solution to number 2. This is type 1, and this is all about factorization. Okay, the first question, number 2, we need to factorize 3x cubed minus 6x squared. Okay, so factoring is getting the highest common factor from each term, and then you do it this way. You factor it out. We usually say factor it out, the common factor, the highest common factor. So there are two things that you have to look at: the numbers and the variables. Okay, starting with the numbers, the highest common factor of 3 and 6, meaning the highest divisor for 3 and 6 is 3. So we factor that out. For x cubed and x squared, we get the one with the smaller exponent. That's the highest common possible for the 2, so x squared. And then if you factor that out, so you say factor it out. Factoring it out, we have 3x cubed. We simply divide it. 3x cubed divided by 3x squared. That is simply x. Okay. And then 6x squared divided by 3x squared is 2. If you look at the factored form, if you will distribute, you should be able to get the given expression. And that will tell you if you have factored it out correctly, or if you have factored it correctly. Now note that when you factor out the expression 3x squared, you have to be sure that this is the highest common factor. You cannot just have 3x. Okay, it should be 3x squared, because the highest common for x cubed and x squared, because x cubed is x times x times x, and x squared is equal to x times x. So the highest common is x squared. That is x times x, x squared. Okay. Letter B. Let's go to letter B. In letter B, we're supposed to factor 16 m squared n cubed minus 24 m n squared. So again, we look at the highest common factor for each term. We start with the numbers. For 16 and 24, the highest common factor is 8. For m squared and m, the highest common factor is m. And n cubed and n squared, the highest common factor is n squared. So if you factor out 8m n squared, the 16m squared n cubed becomes 2mn, because you're taking away 1 from square and then 2 from cube, so you have 2mn. And then for 2m, or 24mn squared, 24 divided by 8 is 3. Then m by m, so it's 1. N squared by n squared is also 1, so you only have minus 3. Again, to be sure if you have factored it correctly, simply multiply, distribute, and if you get the same expression as the given, then your factoring is correct. So that's 16m squared n cubed, that's correct. And then this is minus 24 m n squared. Okay. Letter C. J squared minus 121. Now, unlike A and B, there is no common factor for j squared and 121. So we have to check if this is some kind of a special expression that requires special factoring methods. Okay. Now, if you recall the different examples that we had in class, we actually have a special case of the form a squared minus b squared, which is what we call the difference of two squares. The difference of two squares, when factored, is the a minus b times a plus b. Or if you want to have the plus before the minus, so a plus b and a minus b. So if the expression follows a squared minus b squared, the difference of two squares, then you can factor it easily by having a minus b and a plus b. Okay, so how do we apply that for j squared minus 121? J squared minus 121 is the same as j squared minus 11 squared. So this is equal to j plus 11 and j minus 11. See, that's your a and this is your b. So that's j plus 11 and j minus 11. The difference of two squares. Okay, next. In letter D, you are given 27 m squared minus 48. Now, in letter C, we were not able to find any common factors for j squared and 121. But that is the first thing that you have to check. Okay? Whenever you factor any expression, the first thing that you have to check is there a common factor for the two expressions? And you have to find the highest possible common factor. If I look at 27 and 48, I could see that somehow, or I notice that 27 and 48 are divisible by 3. So 3 is a common factor. So I have to think, is that the highest possible? Then we can try. Now for the case of m squared, there's no m in 48, so you cannot factor out the m. So first, what we can do, we factor out the 3 because it's a common factor for 27 and 48. So dividing this by 3 means 9m squared. Dividing 48 by 3 is 16. And look at what we have right now. Now, after you do factoring by the highest common factor, sometimes the remaining expression can still be factored. Okay, unlike the previous, the first two items, once you factor out the common factor, you can't do anything about the remaining expression. But here, if you look at 9m squared minus 16, it seems like it's a special expression because 9 is a perfect square, 16 is also a perfect square, and this is, or the operation involved is subtraction. And it follows exactly the form a squared minus b squared, the difference of two squares. So that means we have to still factor this into two more factors. So again, 9m squared minus 16 is equivalent to 3m squared minus 4 squared. And that your a is 3m and your b is 4. So the factored form will be 3m, that's your a, and then your b, 4 and 4, plus and minus. Okay, some people can do it in a very direct manner. They take the square root of 9m squared and they get 3m. They take the square root of 16, which is 4. So that's how it will provide you 3m and 4. And then the second factor obviously will have the same values, 3m and 4, and all you have to do is to take the opposite sign of plus, and that is minus. Okay, so all in all, the factored form is 3 times 3m plus 4, and then 3m minus 4. Okay. Let's see letter E. Okay, in letter E, we have x squared plus 20xy plus 100y squared. Okay, if you're given, again, any expression, the first thing that you have to check is there any common factor? So we have to check. There's an x, there's an x, there's no x. So x is not a common factor. This is 20, this is 100. Although they're both divisible by 2 and by 10, the coefficient of x squared is just 1. So you cannot factor out 2 or 10 for this expression. In the case of y, although we have y for the second and y squared for the third, there's no y on the first term, so we cannot factor out the y from here. Okay, so we have to look at it and try to check, is this some kind of a special expression again? If you look at it, if you look at the first term, it's a perfect square. And if you look at the last term, it's also a perfect square. So note, 100 is 10 square, and then you have y square. So that's a perfect square expression. Okay, when you have a perfect square, which is a trinomial, this expression could come from a square of a binomial. It could be a plus b, or an a minus b square. And the expansion for each is a square plus 2ab plus b square, and a square minus 2ab plus b square. Okay, so somehow the given expression follows the format a squared plus 2ab plus b squared. We just have to check. Okay, the middle term is 20xy. So is 20xy the same as 2 times our a and our b? Now what is our a? The a is the square root of x squared, so that is x. The b is the square root of 100y squared, so that's 10y. So is 20xy equal to 2 times x times 10 times y? If you simplify, this is 20xy. So it follows the format of this, meaning the factored form of x squared plus 20x plus 100y, or 20xy plus 100y squared, is simply x plus the b, which is 10y, and then square. Or you can write x plus 10y times x plus 10y. Okay, so this is more on recognizing if it is a special form. Is it a perfect square trinomial? Is it an a plus b square form, or is it an a minus b square form? And then all you have to do, you check the middle. Is the middle twice the product of a and b? And that's what we check here, right? 2 times ab is 2 times x times 10y, and which is also equal to 20xy. And the moment that's the case, then the factored form is simply x plus 10y, that's your a plus b squared. Okay? I think we'll stop there for this video. We'll make another one for number 2f to number 2j. Okay, so I hope you were able to understand the explanation for each item. Note that every item is different, although there are similarities in terms of how to simplify expressions, but every item here has a certain kind of approach needed for them to be factored, or for it to be factored. Okay?